All right, we're going to go through report sheet experiment 17. So number one is just data, mass of your sodium carbonate you weighed out. Two, also data, the volume of HCl required to reach the endpoint. Three is a calculation. You have to use your balanced chemical reaction where 2 HCl react with the sodium carbonate. And so you have MV over C is equal to MV over C. But our sodium carbonate was a mass, so we're going to use the mass over molar mass divided by C. So molarity of HCl is what we're looking for. Volume converted to liters, 0.01422 liters. The coefficient for your HCl is 2. Your mass you weighed out is 0.05430 grams divided by the molar mass of the sodium carbonate. And the coefficient of that is 1. And you get 0.07205 molar HCl. All right, and you do the other two. The data that I have is those three. So you add them up, divide by 3 to get the average. Do your standard deviation to 1 sig fig, and then you write your average using that standard deviation, which says your error is in the third decimal. So you give it to 3 decimals. Then you have your data, your mass of your unknown you weighed out, and you put it in a 100 ml flask. And then your unknown volume that you use in your titration is listed here. All right, and so we want the mass, all right, in this 20.45 mils. We know that the entire amount is in 100, so the 0.9102 is in 100. What mass is in the 20.45? And that is the 0.1861 grams. You do your titration, all right? So data point, what volume of HCl required to reach the endpoint? 14.30 mils. All right, again, the same balanced chemical reaction. All right, same reaction. So MV over C is equal to MV over C. We now know the molarity of our HCl. We calculated above. This time we want to find the molarity, so we can use the milliliters of our HCl, we can use the milliliters of our unknown. All right, coefficient for HCl is 2. Coefficient for the Na2CO3 is 1. All right, so then you solve for the molarity. Push the buttons, get the molarity of your unknown. All right, so now we're looking for the mass. We have the molarity. All right, that's moles per liter. We know how many liters in our titration. Was 0.02045. We had to convert it to liters because liters cancel liters. We want the mass. So we have to use the molar mass, which is 105.99. We get our mass of pure sodium carbonate in that unknown. All right, to get moles, you take your mass, divide by your molar mass, and you have your moles. Then it asks for moles of Na2O. And so the mole ratio is 1 to 1. So whatever number you got for 413, it's the same number for 14. Then it asks for the mass of Na2O. So use the molar mass of Na2O, which is 61.98. And you get the mass of 0.03100 grams. All right. And so now we are asked for the percent. So part over whole times 100. So we take the mass at 0.05301 divided by the total, which was 0.1861 times 100 is 28.48%. Average, you simply add them up, divide by 3. Percent of your Na2O, the 0.03100 divided by the total mass of unknown of 0.1861 times 100 is 16.66. You have 2 other runs. You take the average, add them up, divide by 3. You get the standard deviation. Calculated it on this data, it'd be 0.4. And so you would give your answer to 1 decimal, 17.1 plus or minus 0.4%. And that is a quick how to fill out the report sheet.